Okay, it's a past paper question on coordinate geometry. It says the point A and B have coordinates 1, 5, and B, sorry, I should write that in there, is the point minus 2y. Find an expression for the gradient of the straight line joining A and B. So our gradient then of A and B is going to be y2 minus y1, so that's going to be y minus 5 all over minus 2 minus 1, so that's going to be minus 3. So that's that bit done. It then says that the point C is the coordinate 2 minus 3, and it says that A, B, C is 90 degrees. So B is the point kind of in between. It's going to look then kind of something like that. So we have A and we have B and we have C. Find the possible values of y. So we want to work out the gradient of BC. We've worked out our gradient of AB. So our gradient of BC is going to be, let's see what way we'll do it, y2 minus y1. So it's going to be y minus minus 3 plus 3 all over x2 minus x1, and then that's then going to be minus 4. So let's take a look at our two gradients. This gradient here and this gradient here, and these two gradients are supposed to be perpendicular to each other. So either if we multiply them together, they should give us minus 1, or 1 is a negative reciprocal of the other. So let's set it up that way. I'm going to go for y minus 5 equals minus 3, and those two things must be equal if I turn this one upside down and change it from a plus to a minus. So that would be that one there. I hope that makes sense. I've turned it upside down and I've changed in my positive to a negative. So that's where that comes from, because we just need to solve this. We're going to cross multiply here, hopefully that's okay. So y minus 5 upon y plus 3 equals minus 12. If I do FOIL for that and multiply it out and then take the minus 12 over the other side, I'm going to get y squared minus 2y minus 3 equals 0. Run out of space here, so we'll go up here. Factorizing that, it's going to give us y minus 3 upon, what's that, y plus 1 equals 0. So my two values of y are 3 and minus 1.